Hello, everyone. Good evening, good morning, good afternoon, or wherever you are in the world. We hope you're being safe, you're wearing a mask, you're practicing safe distancing, and you're getting vaccinated. Welcome to the June meetup for OWASP Ottawa. My name is Garth, and I'm one of the volunteers for OWASP Ottawa. This evening, we're going to have a presentation on architecting for security in the cloud. We're very excited about this because unless you haven't been working a lot lately, you will probably have had some sort of work associated with or interviewed about the cloud. And despite it just being somebody else's computer, we all know that the first thing they tell you to do when working in the cloud is to not lift and shift. And of course, the first thing that everybody does when they work on the cloud is lift and shift. But before I start a rant on the cloud, I'd like to introduce our presenter this evening, Josh Sokol, who has a distinguished career in that he spent 4 years on the OWASP Global Board of Directors. He's a creator, CEO, CISO of SimpleRisk, the open source risk management tool, and he's also presented at Black Hat. So we're very fortunate to have Josh with us this evening. Welcome, Josh.
Thank you, Garth. It's a pleasure to be here. Hey, OWASP Ottawa, good evening. All right. We are going to talk today about architecting for security in the cloud. Let's see if I can share my screen. How do I make this thing go live? There we go. Beautiful. Somebody else does it for you. That's how it should work. So as Garth said, I'm Josh Sokol. I'm coming to you guys live from Austin, Texas right now. Actually, Round Rock, just north of there. I'm really excited to be there. We were talking beforehand, and Canada is actually one of my favorite places to travel. So Garth gave a great introduction. I'm not going to go into this too much. I did spend about 4 years on the OWASP Foundation Global Board. It's a great place. It's a bunch of really cool people, and you can help to influence the OWASP Foundation. So if you get the opportunity, please go ahead and run for the OWASP board. It's pretty awesome. Man, Garth, you couldn't have said any better than this, right? What is the cloud? And really, it depends on whose shoes you're walking in. If you're a customer, it's software as a service, right? I just go and I pay somebody, and they're going to run stuff in the cloud for me, and that might be, something like Microsoft O365 or Gmail. It might be something like a Salesforce system. On the hosting side, it's somebody else's data center, it's somebody else's computer, and we're just a tenant in that environment. So cloud is kind of what we make of it, and that's just the public cloud, right? There's all sorts of private clouds and things like that as well. So how did this all get started? The challenge really started when I was first building SimpleRisk. When I first built it, it was something that I wrote for National Instruments. It was a risk management system that I built for use on premise. It was internal use, and it was just this kind of PHP-based application. And later on, I decided to open source this because I realized that other people had risk management needs, and they would be able to use this thing too. And the business of SimpleRisk actually came out of the result of the users who said, yeah, this is great. I like the application, but I really don't want to host it myself. I want to have it in the cloud. And so in my case, the cloud was really leveraged for agility. I wanted to basically, I didn't want to have to host servers out of my house. I didn't want to have to rent space in a data center. I wanted to be able to just throw stuff up in the cloud and have it work. But because of the risk and compliance data that SimpleRisk hosts, security is a big concern. It always should be a big concern. And that's the reason why that whole lift and shift that Garth talked about is so dangerous. If all we do is lift and shift and expect everything to just magically happen, bad things are going to magically happen to us. It's not the kind of thing where we can just throw stuff up there and have it be safe and secure. So really what we're going to talk about today is how do we make that secure? What are the things we have to keep in mind when we move into the cloud? So let's talk architecture for a second. SimpleRisk is just a PHP web application. We can run on Apache, Nginx, IIS. It really doesn't matter as long as that system can run PHP. And then it uses a MySQL database as a backend. Now, This is an OWASP group, and I know exactly what you guys are thinking. You're going, you're writing in PHP. That's so insecure, right? And let me tell you. So in 2015, White Hat Security did this website security statistics report, really interesting data that came out of that. And basically what they said is at present time, we can say that all the aforementioned items, language, industry, organizational size, development process, they don't matter much. And if they do, it's only slightly under some very specific conditions. All right. So if you don't trust White Hat, that's cool. White Source, another organization, came out and effectively said the same thing. They were looking at the total number of reported open source language vulnerabilities, and there's definitely vulnerabilities in PHP. No qualms about that. But there's plenty of vulnerabilities in pretty much any other operating system or programming language or anything like that. And in reality, a lot of it is up to the person who's doing the development. You write bad code, you get bad results, right? So why did I use PHP? Why was that the language that I chose? Well, one really nice thing is the same code works across all these different platforms. I can run on Windows, I can run on Unix, Linux, it doesn't matter, Mac. The same code works. The other thing is installation is relatively simple, right? You can find guides all over online on how do I install a LAMP server. You run some instructions that somebody else gives you, and all of a sudden you're up and running with a LAMP server. Pretty simple. And then the last reason is there's lots of documentation. For when it's not simple, there's all sorts of references. You can look at different websites, and they're going to tell you how to do things. But for me personally, the reason why I looked at is I just knew PHP. I'd been writing in PHP for a very long time. We talked before this about music. I used to play in a band. I wrote a whole band website in PHP. So it was the language that I was most familiar with. And when your vulnerabilities are based on the fact that you either know a language or don't know a language, most of these vulnerabilities are going to find their way in when you're programming in a language that's unfamiliar to you. So for me, that was the way to go. But before we kind of get into the actual physical infrastructure and things like that, let's talk about some generic coding best practices, right? These are the things that OWASP coaches us on, regardless of the language. So things like input validation, making sure that the stuff that we're doing, data coming in from the users, is appropriate. You shouldn't trust the users. You should make sure that that input is validated before you ever use it. Output encoding, preventing our cross-site scripting vulnerabilities and things like that by converting all of our greater thans to ampersand GT and so on. Using hashed and salted passwords, only using it for comparison so that we're not actually storing passwords in our database. Using industry standard crypto algorithms, and then checking for authentication and authorization. These are all kind of standards coming out of the OWASP Foundation for coding best practices. And so we want to make sure that when we're writing our application itself, that we're adhering to these best practices. Now, in terms of architecture, I had the benefit of starting from nothing. It was greenfield, and I recognize that not everybody has that luxury. But even with that advantage, we're still going to continually evolve, and we're going to still find newer and better ways of doing things. And so in this presentation, my goal is to build our defenses from the inside out. We're going to start with that green field and then kind of look at what are the things that we need to add in order to be secure. So starting with our architecture, we have to start with a secure web application. In my case, it was Serverless. In yours, it's whatever application you or your organization are writing. And the first challenge is really ensuring that we stay up to date, that we have the latest code. We avoid number 9 on the OWASP top 10, which is using components with known vulnerabilities. So how do we keep the application updated? And there's a couple answers. The first one is, hey, you should be using a GitHub repository. Private GitHub repository, public, doesn't really matter. We use both at Serverless depending on the use case. But the idea is once it goes into that repo, you have access control over who can push out changes. You have auditability over who makes those changes and what changes were made. And it's very simple to roll back changes if they break things. So if you use GitHub or any sort of source control repository as your kind of code repository, so all your stuff is sitting in there, you're ensuring that you have these pieces in place, which help a lot. The other piece is automation. So we use Chef. Automation tools can check for updates, they can do deployments, things like that, but they really ensure that things are happening in a very standardized manner. So the servers know when new code is made available, the code automatically gets rolled out to those servers. Humans make mistakes. And so when you start building automation, you're actually minimizing a lot of those mistakes that people will make. Oh, I forgot to add that thing, or, oh, I did that on that system, but not on that system. Ensures that our configuration is going to be consistent across all of our different environments. And even better, you can even have different dev, test, and prod environments, and you can do different things in each environment, have different configurations, and so on. So at this point, our architecture looks something like this. We have our web application server in the middle. We've got our GitHub repo that's pulling data from, and then we have our orchestration server, our chef or our puppet or whatever, that's kind of helping to move the bits around, so to speak. And so what we're going to do kind of throughout this presentation is we're going to build a data flow diagram. We're basically looking at how data is flowing between the different pieces of our infrastructure. Now, when it comes to our servers, obviously we want to make sure that they're hardened, that nobody's going to be able to hack into those. So a few things that we should consider. The first is routine patching of the OS and the applications. In the AWS cloud, you have something called AWS Systems Manager, Patch Manager, which you can use to apply patches to different systems. You can also use Chef to do automated patching of those different systems. CIS also says you should turn off unnecessary services and enable a host-based firewall with default deny rules. For me, that host-based firewall is kind of key. We like to talk in InfoSec about defense in depth. And so for me, that really is our defense in depth, because we have AWS security groups and we have different ACLs that will prevent certain types of traffic from accessing it. But in a prior life, we had an issue where the network admins decided to drop the firewalls because they were troubleshooting something. And if I didn't have those firewalls on my system, well, you know what? Those systems can now be compromised because they're now publicly accessible. So having that redundancy, having a second host-based firewall, while it may not be a big deal, it's just more layers of defense in depth. Now, when it comes to administering your servers, you should make sure that you have some sort of secure access. If you are in the AWS environment, they have something called Session Manager. Session Manager is amazing. It is awesome. We've deployed it out. And all of the sessions are proxied through AWS. So it uses their identity and access management controls. You can use multi-factor authentication through it. But the cool thing is there's no publicly accessible interfaces. You don't have to allow SSH at all to a public system, because you're sending all that traffic proxied through AWS systems. Now, if you can't, if you aren't in the AWS cloud, if you're doing something else, that's cool. Kind of the old standby is using some sort of a bastion host. So you basically have a system that's your dedicated SSH host. You use firewalls to restrict the source for all inbound SSH traffic. It's only publicly accessible on this administrative interface. You lock it down further with a VPN. So you're saying only people who log in through the VPN can access this guy. Disable root access, restrict sudo privileges. And the whole idea of this is that you can focus your security efforts in that one location. You harden that bastion host beyond any of your other systems, because that's going to be that point of access. So at this point, our architecture looks something like this. We've added our bastion host or our AWS session manager, and that has that SSH level access onto our systems. Now, our next piece is going to be our database, right? We're going to add in our database. In the case of Simple Risk, it's a MySQL database. So how do we secure that database? And this is where we start looking at kind of native database security. So long and random passwords for database users, using least privilege. So with database accounts, you don't have to give an account access to every single permission on the system. There's things like giving it access to read, to write, to select, to update, delete, those kind of things, without giving them access to be able to change permissions, to add users, to execute, right? That's where we start getting into trouble. So this is where that concept of least privilege, another very common security idea or concept, starts to play in. We want to make sure that we are applying least privilege to our database permissions. And then another important thing, kind of going along the lines of that, the firewall, restricting host. Restrict the host user to only the application servers. So what you're saying is, I don't care if somebody's coming in from some other point on the network, if they're able to stand up another server in the same subnet, it doesn't matter. The only ones who can talk to this server is our application server. So we're really kind of limiting that scope. In terms of AWS, security groups are, they're the end all be all, right? You have to use security groups to basically say, this system talks to this system. And so in the case of the database, the only thing that should be talking to my database is my application servers. And any queries that are going to be run and any connections that are going to happen have to come from that system. The other important thing is you should make it not publicly accessible. One thing that I highly recommend is when you create your subnetting in AWS or wherever you're doing it, create a public subnet. That's for things that are going to get exposed publicly. Create a private subnet. That's kind of the inside of that for, if you have a load balancer, your load balancer will connect to servers that are on that private subnet. There are things that are likely going to be exposed to external assets, but they're not external themselves. And then create a sensitive subnet, another subnet that's on even further inside that only your private subnet can talk to. And so if you create those kind of architectures, you're basically restricting what tiers can talk to which, and you're further limiting the security exposure that you have there. So at this point, our architecture looks something like this. We now have our database. We're making MySQL connections to that. Now, let's push pause button on our architecture for a second, because I want to talk about a fundamental concept in evaluating our system security. And that concept is called attack surface. If you haven't heard of attack surface before, this is the sum of all the different points or attack vectors where an unauthorized user or the attacker can try to enter data to or extract data from an environment. So this is all the different places somebody's going to attack us, right? So think about like a castle, right? There's no better way to illustrate an attack surface than a castle. And so you look at this castle. This is a pretty cool looking building, but how secure is this, right? Not very. I can break a window, I can kick in a door, I can climb onto the roof. I don't see any cameras out there. There's no moats. Really, this while it's a castle, it doesn't seem to be very well protected. And so really our goal here is to minimize the attack surface. We want to make it as hard as possible to attack this castle. And so what we do, we put up some walls, right? We start to build a fortification around the outside. We have towers on the outside. We have a gate and a drawbridge. So now we're starting to make it much more difficult for somebody to attack our castle on the inside. All right, well, we're not done yet. Of course, we have to add some archers, right? Those archers are going to be able to take out people who are coming towards our castle. And then we add a bunch of boiling oil, and we probably pour a moat around there. And of course, our moat has to be full of some alligators and probably some sharks with laser beams, right? Frickin' sharks with frickin' laser beams. In any case, you guys get the idea, right? Our goal here is to minimize the attack surface. We want to make this as small as possible so that somebody's going to go, yeah, I'm not going to attack that thing. That's way too hard. I'll go and attack that other thing. There's this whole concept of the slowest buffalo, right? The predator that's out on the plains, they're going to go and they're going to attack whatever the slowest thing is. Maybe it's an elderly buffalo, it's going to be a baby buffalo, whatever. They're going after that slowest buffalo, and you don't want to be the slowest buffalo. You don't necessarily have to be the fastest, but if you're the slowest, you're the one getting taken down. All right, so let's push play again. Let's resume. So what is our current attack surface? And we've since kind of taken this approach a step further. As I mentioned, we laid out public subnets, private subnets, sensitive subnets. The Bastion host was moved into an isolated VPC with access into other dedicated VPC environments and so on. So our attack surface at this point is that area in red. It's basically our Amazon console. So where we log into AWS, we need to look at kind of that interface, and GitHub, because that's where our code is coming from. So if somebody can push something into GitHub, well, that can end up being deployed into this whole other interface. So what's our next step here? Well, we need to enable access for our customers, because our environment, if it has zero connectivity, it's not useful to anybody. And we need to enable access for administrators, because people have to be able to do things on that system. If things break, they have to be able to troubleshoot and so on. So we add in that, right? We have our load balancer. It acts as a proxy and allows for this kind of end-tier architecture. So you can kind of see there that we have that load balancer on the inside. Our remote user can communicate with that via HTTP or HTTPS. And then we have that Bastion host, which or AWS Session Manager, which the remote user could connect to via SSH. So what are our attack vectors at this point? Well, our attack vectors are going to be insider access. So, if you have somebody who's inside and they have access to the things, honestly, it's kind of game over. There's a few things that we can do there, but if they have that level of access, we have problems. If our attacker compromises Amazon in order to change configurations for the environment, if they compromise GitHub in order to push malicious code to the environment, if they find a vulnerability in our application and are able to access the environment that way, or if they find access to the Bastion host, that's effectively our attack vector. And so by putting all these other controls in place, we've limited it to these handful of things, 5 things that we can define and we can try and plan for. So how do we do that? Well, let's look at our insider threat. With the insider threat, as I said, this is hard, right? It's hard to mitigate against insider threat because these are effectively trusted insiders. So how do you make them trusted insiders? That's really the key here. The first is background checks. Make sure you know who your employees are, what their motivations are, and kind of how to protect the environment there. And number 2 is limit those who have access. Does your receptionist need access to get onto the customer server? Probably not. I would say in all likelihood, they do not, right? Does the janitor need that access? Definitely not. So, you have to look at the different roles of the different people and kind of scope that down. In my organization, there's 3 people that I trust, including myself, to access those servers directly. And for me, that's enough where if something bad happens, I have a little bit of leeway. I can be like, hey, so-and-so, can you go ahead and handle that? Yeah, then we can do that. If I'm out of the office, that's cool. But it's not an insane number of people where I'm going, oh, well, all those people have access. And if that person was compromised or that person or that person or that person, then we're screwed. The other attack vector here is Amazon. And again, limiting who has access, right? We want to make sure that only the right people have access to the system. We should have role-based functional authorization, ensuring long and random password requirements. So you're not going to get in with a password, and then requiring multi-factor authentication. In my prior life, I worked at National Instruments. I ran the information security program there. And I'll give you guys a little bit of a story here. We were having so many issues with people who were phishing. They would send these emails to our employees. The employees would, they didn't know better. They were clicking on it. They were entering their passwords, and they were getting compromised. And literally within minutes, somebody was going and logging into their account and looking at their emails and things like that. Usually out of a place like Lagos, Nigeria, something like that. What happened was we ended up using multi-factor authentication. And we required every single employee to do multi-factor authentication if they were logging in. And that cut that attack off cold. They were no longer able to, they still compromised usernames, they still compromised passwords, but they could not log into the environment because they didn't have that other token. And I'm sure they started trying to figure out, well, how do I phish people for that and things like that. But we upped our game. We made it a lot harder. We were no longer that really, really slow buffalo, the grandma who was about to pass away anyways. We were now, somewhere in the middle of the pack. And so that's incredibly important. GitHub. So that's our next attack vector. Again, limiting who has access, right? We have a recurring theme here. So making sure that only the people that you need to have access are the ones who have access. We should ensure that we have long and random password requirements, require MFA in GitHub, and then audit changes, right? You have the whole idea of having a version control system is auditability. You can look at every single change that's in there and should look at every change in there to verify that's what you expect to be in there. Our attack vector for web application, this comes a lot to that OWASP top 10, making sure that we're doing all those different things. It's probably worth mentioning that the OWASP top 10 is the top 10. It's not the everything, right? And so anytime we talk about the top 10, it's an educational document. It's a great place to start. Everybody should know what the top 10 is and how to correct it, but it's not the full list of application vulnerabilities. So we want to make sure that we're evaluating kind of the broader scope there. Sending traffic to HTTPS by default, so redirecting our HTTP to HTTPS. Not only is that more secure, it also gives you boosts in the search engine rankings if you're running a website or something like that. using a secure HTTPS configuration, which means using real SSL certificates. You can go to Let's Encrypt, get a free SSL certificate. You can use certbot to update that on a regular basis. If you're running an enterprise, I highly recommend, there's an organization called SSLmate that does SSL certificates through it, Let's Encrypt, but they have all the automation pieces around it, APIs and things like that, makes deployment a breeze. And then making sure that you're using TLS 1.2, or in a lot of cases now TLS 1.3, with strong ciphers enabled, and honor the cipher order. I actually gave a talk at OWASP Austin a while back where I talked about, during the crypto party, how do you actually configure a secure Apache configuration? How do you get that A+, which is what we strive for. Using an IPS or a WAP system, and then of course, like I said, the OWASP top 10, the application security pieces. The last one here is remote access. So I mentioned SSM. If you're on the AWS cloud, use SSM. It doesn't take that much effort. It uses that identity and access management platform. It can use multi-factor authentication, and it means that your attack surface is reduced because you don't have to run an SSH server. So it actually simplifies things a lot, and it's free. It doesn't cost you extra money to do SSM. So why not? If you can't do SSM, if you have to do SSH, make sure you're using MFA. Use long and random passwords for the SSH user. You can use key-based authentication as well. So you can use a combination of your key as well as the password that you have for that user. You can use MFA in addition to that. Lots of plugins that you can use in Linux systems and Windows systems to ensure that. Restricting what IP ranges are allowed to talk to our Bastion host. That can be really important because we don't want somebody from Nigeria to be communicating with our system, or Russia or China or any of those others, right? We want to make sure that just us is the one that's talking to that. And this is even easier if you do VPN. So if you do VPN, you say the only thing that can talk to my Bastion host is the VPN server, and the only people who can talk to the VPN have to be authenticated. And that kind of nips that whole thing in the bud. So we're almost done at this point. Just a few recommendations here. The first recommendation that I have is determine what is or is not in scope, right? Your scope can blow up very, very quickly. If you're trying to look at your entire organization, I mean, that's probably going to be years worth of effort. So start looking at what are the things that you can do kind of within your scope, maybe the things that you have the most control over. Start there, start small, build on that. The next one is data flow diagram. So if you can look at how data is flowing between your different systems, that's going to give you the ability to really understand the environment as a whole. And once you understand how data is flowing, then you know where you can and can't stop data, what kind of controls you can put in place. From there, you can identify the attack surface. So what are the different places that data might come into our environment? And then you can identify the threat vectors. The vectors are going to be the attackers, the people who are coming in, the ways they're coming in to attack our organization. And then lastly, plan the mitigations to reduce the risk of the threats. I've given you a whole bunch here. You're not going to boil the ocean. You're not going to implement them all at one point in time, but you have to start, once you understand your attack surface and your threat vectors, then you can start to go, okay, well, if that person is going to be, doing a man-in-the-middle attack and they're going to be sniffing my traffic, then I should probably make sure that I have HTTPS, right? And do HTTPS by default. So understanding kind of how that chain works helps us to figure out what mitigations to put in place. So with that, we're basically done, but I'm here to answer questions that you guys have. So I'm going to push pause on the presentation and speak up. Let's see what we got. I am not hearing you, Garth. You're muted.
I am muted. Nobody does that. In COVID, nobody sticks on mute and yaks away.
That's right.
We've had requests for you to play guitar.
Oh man,
I know Ottawa's a tough crowd.
We'll save that one for the end. We'll see what we got. But I appreciate it. Yeah.
So I'm just wondering if you've had experiences with different cloud providers. In fact, I've recently learned that even Alibaba has their own cloud service, in terms of that huge market in Asia. But I've had experience in both AWS and Azure, and I do notice very different approaches in terms of security posture. And I'm wondering if you have any experience in that and anything you can share.
Yeah, I have a little bit of experience with that. So I've played around with Microsoft. I've played around with Google. My initial implementation of Serverless was actually in the IBM SoftLayer cloud. What I can tell you is with SoftLayer, they, at least, and this was 7, 8 years ago, the security controls weren't as obvious as with Amazon. With Amazon, they have very pointed products. This product does this thing. It was very easy to apply, very intuitive. SoftLayer, I kind of felt like I would pay a monthly fee for a server, and then if I wanted to apply something for security, like a firewall, I'd pay a monthly fee for that. Amazon felt very like pay as you go. If I want to spin this thing up, play with it, spin it back down, I could do that. I could experiment and kind of try things out kind of as I went along. The feature set between AWS and Microsoft, the Azure stuff, is pretty comparable at this point. And I think Google is probably there. They're probably catching up, something like that. The SoftLayer stuff, I don't know where they're at today. The reason why I initially started with them is I was actually in they had kind of an incubator program where they were helping me to pay for some of the stuff. And so why not, right? If somebody wants to throw some free money at you, you're going to use that to spare up some stuff that way. But ultimately for me, with all the different platforms that I've experienced, AWS has the most features, the easiest, most intuitive interface, and tons of documentation out there. And so when it comes to implementation, I mean, that's really what you're looking for, is you want to be able to understand kind of the landscape. If you want a firewall, you go AWS firewall, search, and boom, it comes up. Here's how you implement it. Here's a very nice document. Here's how you do it. They have all sorts of tutorials. They have things that will walk you through how to set it up on a sample web app, CloudFormation scripts, you name it. So it's really, really cool, kind of the community that's been built around that. And that's kind of the reason why I've gone there. That's not to say that the other platforms, Microsoft or Google or whatever, aren't okay. They certainly qualify as cloud. They certainly have their own features and functionality. But for me, AWS was the way to go.
Right. I know probably during the time that you presented, they probably implemented Shark lasers as a service. The one thing I noticed out of the box is that for the free tier, when you create that initial account in AWS, your administrative account can be MFA'd.
Mm-hmm.
In Azure, that's not the case, and that's another financial tier, which was the first thing that sort of caught me by surprise. And they have various different approaches in terms of initial resource deployments, in terms of how they're either publicly or not publicly accessible in terms of default settings. The one thing I noticed is that you talked about data flow diagrams and your threat analysis and things like that, but you didn't use the magical phrase threat modeling. I'm wondering if that was intentional.
I wouldn't necessarily say that was intentional. I think that the exercise that we did was akin to threat modeling, right? But usually threat modeling, at least from what I've experienced, is once we've already built this application, now we start to decompose it. And so for me, this is more of a builder than breaker exercise. I want to build this up. I want to understand what are the components as I build this. And we're trying to kind of, I mean, it is threat modeling, but we're modeling as we go along. We're trying to figure out how we would break this and then putting the right mitigations in place so that our final outcome isn't, oh crap, we built this wrong, now let's strip it back down and rebuild it again. Our final outcome is something that we can be proud of.
Right.
Yeah.
Fair enough. I'm not personally familiar with Session Manager, but the way you were describing it sounded very much like an open source product called Guacamole, which is web-based, relies on HTML5, and I've had some experience in deployment, but it sounds almost like it's more than that. Are you familiar with Guacamole, and can you compare them?
I'm not familiar with Guacamole, but there's a couple of other platforms out there that are similar to that, where the whole idea is that you're kind of connecting to one system and then that's your bridge. That's your gateway into all the other systems. And so, if Guacamole is doing that, then that's probably pretty similar to this. The nice thing is that it is supported by AWS by default. You basically apply your IAM roles to the system, and then you can create users. Your users' passwords are updated. The MFA for the users works in that environment. And so for me, I basically come in the morning. In my SSH terminal, I type AWS-MFA, hit enter, and then I enter my MFA key, and then I connect to my servers. And everything else just kind of happens magically because I have my identity file, I have my keys, I'm able to connect to those things without doing any additional work or any additional effort. So for me, that ends up being really nice because it's an AWS native thing. I don't have to build a Guacamole server. It happens automatically in AWS.
That's nice. I'm wondering if you can add anything with regards to serverless, because I'm seeing obviously a lot of a feeding frenzy around Kubernetes, and I'm looking at the management and the entire infrastructure, that whether it's managed or not, there's a lot to manage there. There's a lot of tricks and traps to be aware of. And then I see serverless as an alternative, and I'm wondering if you've done any work around that, and if you have any indication around that you can share.
Yeah, so I guess a few things. You mentioned Kubernetes. We actually use Kubernetes in our environment. One of the things that I wanted to do was I wanted to be able to run simplest trials at scale. I want to be able to have people signing up for trials and have them spin up. But I wanted to do it in a secure manner where each one was kind of in their own container with their own database and whatnot. And so I used Kubernetes to do that. I used Chef for the orchestration pieces behind it, and it works really, really well. The one kind of caution that I have for Kubernetes is know what you're doing. With that environment, if you don't have a couple of master servers, if the master borks, all of a sudden your whole thing goes down. We ran into issues with out of memory and things like that. So Amazon will build a Kubernetes platform for you, and then you just pay us to run the thing. If I had to do over again, I might do that. It was still cheaper for us to roll our own. But those kind of resources are, you get what you pay for, right? Which in my case was a really good learning opportunity. In terms of things like serverless, a lot of that is entirely dependent on the application that you're running. And so for me, I had already kind of written my application with the PHP stuff, and I didn't want to have to rewrite anything or integrate it into the serverless architecture. For me, I also had this concept of how do I isolate every single customer. So I was putting them in dedicated virtual private cloud environments and things like that, which ends up being a much better security story than, we're running a serverless architecture and everybody runs through the same system. And, there might be ways to break that shared architecture and things like that. So I guess that's kind of where I'm at. Serverless is awesome for certain things, like if you're running a website or something like that. But if you're running a purpose-built governance, risk management, and compliance program, I kind of shied away from that.
Right. The sort of like the equation, two sides of the equation I look at is the just the sheer complexity of a Kubernetes environment, and then the resource load of running a service mesh like something like Istio on it. You need to have, you really only would want to use things like that give you great facilities, but at a resource cost. And it is non-trivial in terms of that resource cost, versus what's the potential cloud lock-in of serverless. Are you building something that's bespoke to your cloud provider, and then if you want to move, then you have that transition headache? And how independent can that actually be in serverless, where at least if you've got a set of containers running in Kubernetes that is the theory is at least you can move it to a different Kubernetes plane in another cloud provider, and maybe you can run them simultaneously. And then you're using cloud as a utility, and it's that balance between that complex management versus that nimbleness in a cloud environment when a particular cloud provider decides to crank their rates suddenly.
Yeah, and that's a really good point. You want to make sure that regardless of which cloud provider you're going with, you're building something that's relatively portable. So far, AWS rates have essentially remained the same, if not gotten cheaper over the past few years, but we don't know that that's going to happen for forever. And, you want to make sure that if another cloud provider suddenly gets the jump and they're way far ahead, they have better services, better platforms, faster, whatever the case may be, you want it to be relatively easy to make that move, to jump to someplace else. And so, for us, things like having CloudFormation scripts that kind of build the platform for us, using Chef scripts to do the automation, the whole idea of like infrastructure as code. We want to make sure that all this stuff is just bits and bytes, so that when we want to move somewhere else, we basically just click the button, everything just kind of builds for us, and we're up and running. Minimize that. Now, I don't plan on abandoning Amazon anytime soon. I guess you could say I enjoy the platform, maybe even infatuated with the platform. But who knows? Who knows what's going to happen in the future?
Right. I'm sorry to shock you, but we have a question that's not related to sharks and lasers or guitars. Salut, Mathieu. Mathieu has a question. Have you played with AWS WAF, and did you integrate it in your architecture? If yes or no, why?
Yeah. So yes, I have played with AWS WAF. It's pretty awesome. And the ability to just turn rules on is pretty cool. AWS has the ability to use kind of third-party rule sets and integrate those into the WAF. That's a pretty neat feature, neat functionality. There's all sorts of resources in terms of how to build a WAF, and some of those templates that I talked about, where you like literally just click a button and all of a sudden it builds the WAF stack with the sample application, and you can play with the rules. That's all there. I did not, however, integrate that into the Serverless architecture. And the reason why I didn't do that is because with our architecture, what we're effectively doing is we are building a dedicated environment for every single customer. And so when you start to look at the costs involved with that, it gets really, really expensive when you say, I'm going to have this WAF with these rules, and you're paying for different rules and so on for that environment. So you're effectively paying for the rule sets and things like that are out there. Now, that doesn't mean that we're not using AWS WAF in certain circumstances, in certain situations, and that doesn't mean that we're not using other WAFs. But in terms of the AWS WAF, that's kind of the choices that we made there.
When you say other WAFs, so you've pulled something from the marketplace, or are you hosting it yourself within your AWS architecture?
Mod security, so self-hosted kind of thing.
Right.
Yeah.
Right, that makes sense. So your mileage may vary based on your expected traffic stream.
Yes, yeah, for sure.
Awesome. I'm going to give it another second. I don't have any other questions. I don't see any other questions in the Slack. So the next question I would have is really, so what is your favorite guitar?
Actually, you can't see it in the picture, but I will pull it down for you guys. This guy right here, this is called a Gibson L6S. Show you the little headstock here. This guy is basically older than I am. It's from 1976. And there's kind of a cool story behind it. I was working as a co-op at Advanced Micro Devices, AMD, here in Austin. And I was like, well, I got a little bit of extra money. Maybe I can buy a guitar. And so I threw something up on the message board. And I said, hey, is anybody looking to sell a guitar? And this guy from our Sunnyvale office came to me, responded back, and he said, hey, my wife is making me get rid of my guitars. He said, I have this guitar, and he said, it's a very nice guitar, and I'd like for it to go to somebody who will play it. And I was like, yep, that's me. But I had to figure out how to get back from Sunnyvale. And so I actually had a coworker that was traveling out there. I asked him to pick up the guitar for me, and he did. And I paid $200 for this guitar. That's probably a $2,000 guitar. So this guy, this never went to any shows with me, but I did play this in the studio when my band recorded, and it's a pretty sweet guitar. It's kind of like a Les Paul that got run over by a truck. It's pretty thin.
That's an amazing story.
Yeah.
Right time, right place, that sort of thing. I just I just don't understand the requirement to get rid of a guitar.
You know, if I have any advice for people who are fellow guitarists, and my wife and I laugh about this now, but convince your wife that guitars are art and are meant to be hung on the wall and admired, and then you're not buying another obsession musical instrument. You're buying a piece of art that can go on the wall behind you. So, yeah, take that advice for what it's worth.
Noted, and advice on so many different subjects. Thank you very much. So we talked about the cloud. We talked about sharks with space lasers as a service. We talked about guitars on the wall as art, and we talked about relationship counseling. So many different things. Thank you very much. Your information is posted there, so I'm sure anybody can reach out with other questions. I know I'm going to take a look at Simple Risk and see what it's about. But thank you very much for your expertise, your experience, and sharing with us today. And we hope we can make this a recurring event, because I know you have other topics you talk about. So we hope to have you back again soon sometime.
Absolutely. That sounds great. Thank you, Garth and OWASP Ottawa, for having me. Hopefully I can do it in person one of these days. I am fully vaccinated. I'm ready to go as soon as these borders open up and we're able to make it safe. So, yeah, hopefully I'll see you guys soon.
So what are you, 2 Pfizers, 1 Moderna, 1 Pfizer? Or
two
one?
Two Pfizers. We're 2 Pfizers. We are a Pfizer household. My wife, my daughter, and myself have all had that here. So, yeah, we're good to go.
Right. We have more of a blend here.
Very cool.
Awesome. You take care. You stay safe, and we'll be talking to you again soon sometime.
Sounds great. You guys take care as well. Thanks for having me.
Thanks again.